A balanced equation follows the law of conservation of mass. The law of conservation of mass simply states that in chemical reactions, mass is neither gained nor lost. So the total mass of all the reactants has to equal the total mass of all the products. So remember that if a gas is produced, its mass counts as well because gas is matter. If it looks like mass was lost, then more than likely you have given off a gas. If the mass increases during the reaction, then maybe a gas reacted with the reactants to produce a product heavier than what you started with. Atoms can be rearranged into different compounds, but the mass will always stay the same. So here it shows that we started with 10 grams of mercury 2 oxide, and we ended with less grams. We ended with 9.3 grams of mercury because we also produced a gas, specifically 0.7 grams of oxygen. So together, our mass of our products equals our mass of our reactants. So to solve these problems, you're going to pull the masses that they gave you and just put it underneath what it corresponds to. So 127 grams of copper goes under copper. 32 grams of oxygen will go under oxygen. And it says how much copper 2 oxide is produced. The arrow is going to be an equal sign and the plus is a plus sign. So 127 plus 32 gives us 159 grams. So our total product would be 159 grams. The numbers in front aren't making any difference in the problem right now because all of it reacted, so the reactants have to equal our products. This problem says that you have 10 grams of a substance. It was heated for 5 minutes. Then the test tube was allowed to cool and weighed again. Now it weighs 4.8 grams. What must have been produced since it seems like mass wasn't conserved? Well, we must have produced a gas, specifically 5.2 grams of a mass, or 5.2 grams of a gas. So these two will add up to our 10 grams. So a balanced equation represents the law of conservation of mass being followed. So most of the problems that you're going to see in law of conservation of mass are going to be, is this equation balanced and how do you balance it? Before we can balance an equation, first we have to be able to count atoms. So in this problem we have 2 hydrogens because there's a subscript 2, but it's only attached to the hydrogen. So 2 hydrogens, and there's a 1 after the oxygen, it's just not shown, so 1 oxygen. If you have parentheses, then that's like saying 1 aluminum and 3 hydroxides. So there's a 1 there and a 1 there. That 3 multiplies by the subscript. So in this case, we have 1 aluminum because the 3 will not affect the aluminum because aluminum's not in parentheses. While 1 times 3, 3 oxygens, and 1 times 3, 3 hydrogens. We can see that over here. We have 1 aluminum and 3 hydroxides. For this problem, we have 1 aluminum and 3 chlorines. So 1 aluminum, 3 chlorine. For this one, we have 3 Ks, 1 P, and 4 Os. All right, go ahead and pause the video and do these 4 on your own. Restart when you're done. So we have 3 calcium, 1 times 2, 2 phosphoruses, and 4 times 2, 8 oxygens. You had 1 silver, 1 nitrogen, 3 oxygens, 1 C and 2 O's, and then 2 sodiums, 1 sulfur, 4 oxygens. A coefficient is a multiplier. It's going to be a whole number and it's going to be found in front of the compound. When you add a coefficient, it's like saying that I have 3 molecules of calcium fluoride. So if I were to write that out, you can see that you have 3 calciums and 6 fluorines. So when solving these, you can say 3 times 1 and then 3 times 2. So 3 calcium, 6 fluorides. You can also ignore the number in front, figure out how many you have, and then multiply it by that number. So for this first one, we have 3 times 2 gives me 6 hydrogens. And then 3 times 1 gives me 3 oxygens. 4 times 1 is 4 aluminum. 4 times 3 times 1 is 12 oxygens. 4 times 3 times 1 is 12 hydrogens. Again, if that got complicated, you can ignore the coefficient and say, okay, well, I know that I have 1 aluminum, 3 oxygen, and 3 hydrogens, and then multiply it by the number in front. This one, I've got 2 times 1, so that's 2 aluminum. 2 times 3, that's 6 chlorines. 2 times 3, 6 potassium. 2 times 1, 2 potassium, and our phosphorus. And 2 times 4, 8 oxygen. So go ahead and pause the video and do these 4 on your own. Restart when you're done. So 3 times 2 gives you 6 calcium. 2 times 1 is 2 times 2 is 4 phosphoruses. 2 times 4 is 8 times 2 is 16 oxygen. That's 5 silver, 5 nitrogen, and 15 oxygen. 3 carbon, 6 oxygen. 8 sodium, 4 sulfur, 16 oxygen. When writing and balancing equations, step 1 is you're going to write the skeleton equation, like what we did previously in class, where I give you words and then you write the equation. Sometimes an equation will be given though. Then you're going to make sure that you have equal numbers of each atom on both sides of the equation. You can add coefficients where necessary, but you cannot change the subscripts. You can't change a formula. Generally, you want to balance hydrogen and oxygens last since they're usually in more than one compound, but you don't have to. So before we begin, let's see what it means in our balanced equation. Right now we have 1 zinc, 1 hydrogen, and 1 chlorine. On the product side, we have 1 zinc, 2 chlorines, and 2 hydrogens. I have to have equal amounts on both sides. We can easily see from this representation that our hydrogens and chlorines are not equal on both sides. So I can add numbers to the front. I need 2 HCl's to fix my chlorines. I can't just fix chlorines though, because if I fix chlorines, I'm also going to increase my hydrogens. So now I have 2 hydrogens and 2 chlorines. But looking on both sides, I have equal zinc, equal hydrogens, and equal chlorines. So my other coefficients are 1s. You don't have to write the 1s in those blanks, but be aware that if it's a multiple choice question, it may say what coefficients balance this equation. And it'll say 1, 2, 1, 1. Or it may say, what's the number in front of zinc chloride when this equation's balanced? This is not a 0. 0 would mean that I have no zinc and no chlorine, and that's not what we have here. So when it's a blank, that's a 1. Another way that we can balance the equation without writing out all of our symbols like we did on the last one is underneath the arrow or somewhere on your paper, you can list all the different elements. So I have hydrogen, I have phosphorus, I have oxygen, I have sodium, I have oxygen, but I've already written oxygen, and I have hydrogen. Now I'm going to list out how many of each element I have. So I've got 3 hydrogens plus 1. Oh, notice that I already have hydrogen, so I didn't need that last hydrogen. So 3 plus 1 is 4 hydrogens, 1 phosphorus, 4 plus 1, that's 5 oxygens, and 1 sodium. So I've accounted for all of my elements on the reactant side. Now the product side, I've got 3 sodium, 1 phosphorus, 4 plus 1, 5 oxygen, and 2 hydrogens. So looking at this, I have my hydrogens that are messed up, and sodiums are messed up. Because hydrogen's in more than one spot in a couple of places, I'm going to go ahead and fix my sodiums first. So since I need more on my reactant side, I say, okay, well, here's where I have sodium. I need 3 all together. So I need to put a 3 here because then 3 times 1 will give me 3 sodium. Sometimes people get confused because they're like, well, I already had 1, so I just need 2 more, so let me put a 2 there. But if I put a 2 here, then that means I have 2 sodium, but I need 3 all together. So you have to ignore how many you had to begin with and just say something times 1 gives me the number I want. In this case, it's 3. So my sodiums are fixed, but that changed my oxygens. I have 4 plus 3, that's 7 oxygen now. And 3 plus 3, that's 6 hydrogens. So fixing my sodiums messed up oxygen and hydrogen. All right, so now I can fix either oxygen or hydrogen, but oxygen's in 2 spots, so I'm going to fix hydrogen. Hydrogen, I need 6 all together on the product side. So something times 2 will give me 6. That's a 3. So 3 times 2, that's 6 hydrogens. And then I've got 4 plus 3, that's 7 oxygens. So now it's balanced. You may always want to double check that you counted correctly. So I have 3 plus 3, that's 6. 6 hydrogens, 1p, 1p. 4 plus 3, that's 7 oxygens. 4 plus 3, that's 7 oxygens. And then 3 sodiums, 3 sodiums. So again, this is my balanced equation. I can leave it like that, or I can put 1s in those 2 blanks. Doesn't matter. And then finally, the third way of balancing is sometimes you'll have an equation that's pretty easy, and instead of listing out all your elements, you can just do it in your head. So I've got 2 chlorines, and I've got 1 chlorine. So I know I need to put a 2 here. So now I have 2 chlorines and I've got 2 chlorines. So then I go to the next element. Lithium, I've got 1 lithium. I've got 2 lithium. And again, it's 2 because there's a coefficient. So I need to put a 2 here. So now I've got 2 lithium, 2 lithium. So now I check my iodine. And I've got 2 iodine, 2 iodine. So now this equation is balanced. Go ahead and write your equation for this word equation. Restart when you have your skeleton equation. So silver was a +1, nitrate is a +2, barium's a +2, and chloride's a -1. So it says silver nitrate, and that's a solution, so that's aqueous. And barium chloride, it said solution, so that's also aqueous. React, and now our products are silver chloride, so +1, -1, so silver and chlorine. And it's a precipitate, so that's a solid. And then barium and nitrate. The positive has to be written first, and that's a solution. So whenever you're writing your equation, when you're going to balance, you may want to draw a little line and then write your silver nitrate. Plus, draw a little line, write your next one. And I noticed that I messed up on barium chloride. Barium was a +2 and chloride's a -1. That should be BaCl2 there. And so on. So drawing a little line so that way you can go back and balance it. So I'm going to go here so I have a little bit more room since I've already done that. And this is your last way of balancing. Sometimes you'll see a polyatomic ion on both sides. So to make your balancing easier, we can keep that polyatomic ion together. I could do it in my head, but if I'm confused, then it's always a good idea to list out my elements. So I've got 1 silver and I've got 1 nitrate. Notice this is not in parentheses and there's no number on the outside of those parentheses, so it's just 1. I've got 1 barium and 2 chlorides. On the other side, I have 1 silver, 1 chloride, 1 barium, and notice 2 nitrates. So you only have 1 polyatomic ion unless it's in parentheses with the number on the outside like this one. So to balance, my nitrates and my chlorides are messed up. So I'm going to fix my chlorines first. So to fix chlorine, I need to put a 2 in front of this. That'll give me 2 chlorides and 2 silvers. So now my silvers are messed up and my nitrates. So to fix silver, I need to put a 2 in front. So that's now 2 silver, and that also changes my nitrates. Now I have equal amounts on both sides, so this is a balanced equation.